everyone. So in this session I will design the patch antenna for 28 gigahertz frequency. So this frequency can also be, you can also consider for 5G application. One of the main frequencies for the 5G communication. So that also you can think as of this antenna can be a 5G antenna, one that, because once it is designed for 28 gigahertz on either of the frequency which is allotted for 5G communication, in that case this will be your 5G patch antenna. Okay, so similar, I'll click on HFSS in this case also, and then I will ensure this solution type will be model. Okay, modular units will be, should be in mm only, that is millimeter. Now I'll start that same procedure, same flow I'm using, that is making substrate, then ground, then patch. Okay, so I'll click on box. I will draw this box. Okay, now click on the box one, name it to the substrate. Okay, in this design we will see for the inset feed and how to subtract that part from the patch. Regarding this, I am taking the substrate as 5880, that is Roger RTD, right, which is 2.2 dielectric constant. Same color I am taking as brown only, little bit lighter, and it should be transparent. Then create box, give the dimension as minus ls by 2 comma minus ws by 2 comma ts, sorry, 0 it will be there. Okay, now anyway it will ask for the values of those parameters. Now ls here in this case is 7 mm. Okay, ws will be 8 mm I am taking. Okay, and then ls I have to give, ws is there, then ts will be there, which is 0.508. Okay, I'll click on apply. Now again I'll click on Ctrl plus D so that it will get fixed in the workspace. Now I will draw the ground plane. So ground plane also, I'll select the box, click on this point, make sure it will match it. Now click on the box one, name as ground. Material will be copper. Then yellow color I'm taking. Okay, now again regarding the dimension, it has to be minus ls by 2. As you can see, already by default it has came as minus 3.5, minus 4 means ls by 2, ws by 2, because ls is already 7 mm, ws is already 8 mm, so half of it is minus 4, 3.5, like that. Because I have chosen the coordinates exactly at the same as of substrate, so that's why it is showing no problem. It is having no issue with the alignment and all. But anyway, the thickness will be minus TP, because thickness of copper cladding we have to give, which is 0.017. Apply. Okay. Now patch we will design. For patch also I'll select the box named as patch, vacuum, copper, yellow. Okay, I'll click on apply. Then create box, give the dimension as minus LP by 2 minus WP by 2 comma 0 comma TS, because on top of the substrate we have to design this. So minus LP is 5.5, which is a length only. WP is also length, which is 6.7. So it has to be LP, it has to be WP, and it has to be TP. Okay, now we will design our feed for this antenna, patch antenna. For that, again, you can go to the box, design random way. Okay, name as feeder, material as copper, yellow. Okay, apply. Okay, dimension I have to give us minus LP by 2, LP by 2, comma, it has to be minus WF by 2, comma, 2 minus km. Let me remove one of the signs. Then on TS only. Now it will ask for the dimensions for the WF. Okay. Now WF as I'm giving us for the 50 ohm feed, in this case of 28 gigahertz with the dielectric constant 2.2 and the dielectric height 0.508, it is coming around to be 1.55. So I have taken 1.5 only. Okay, okay. Then click on X size. For X size, it will be dimension is LP only. Sorry, LF it has to be there. LF again it has to be 0.75. WF and TP. Okay, as you can see, it has been applied. Okay, now I'll do this first of all. Okay, now what we do, we will add this, which is feed and patch. Okay, modular boolean unite. Okay, now it has been added. Now we are making it for insert feed because it is not fully matched with this kind of thickness generally. So I have used insert feed. In order to make an insert, some small shape I'll create it, small vacancy I will create generally at the edge of this main feed. Okay, so that we can do easily. In this case also I will define it this kind of things only, and give the name as insert. I will give another material so that I can distinguish and it will not come in same area, same length like that. I'm giving a dimension position as 0, 0 ts only because I'll be using move or you can say the surface option in order to move that in inset slot to its position. So it will be IL, and IL has to be 0.8 I'm giving. Width also I'm giving as IW, which has to be there in 0.4. Then Z size it has to be TP, same only I'm giving. Okay, now it has been created. So what I'll do, I will simulate it because anyway it is on TS only, so I will no need to bother about the alignment. What I'll do, edit, click on insert, right click, edit, then arrange, then move. Again I will see whether it is properly aligned or not, because when we will be going to subtract it, it should not give problem to us. Okay, now again I'll do what I'll do. Again I have to, since on the other side as well I have to create this vacant place. So I'll copy this insert and paste it, and later on we can move it to the second side of the main feed. So I will do Control plus C and V. This also I'll select, edit, arrange and move. What we will do is select and select. Okay, now again I will check whether it is properly aligned or not for both the cases. Yes, it is properly aligned, because if it is not properly aligned, so whenever we are going to subtract it, it will not subtract. Maybe some portion of the substrate itself can subtract. So this is also possible. At that time we will not come to know what is the exact issue. Okay, what we'll do now, patch I'll select, and insert also I'll select. We'll go to the modeler, boolean and subtract. Now in this case you should remember that blank parts and tool parts means what should be subtracted from this operand that has to be there in the tool parts, and from which the element needs to be subtract, that part has to be kept in blank part. Okay, I'll click on OK. As you can see, one thing has been removed. Okay, or you can say etched. Again I'll select the patch, I'll select the inset, I'll go to the modeler, go to the boolean, subtract it. Again click on OK. Okay. Now save this design. I'll save this design to somewhere else on my system. So I'll select it, project 2. Okay. Yeah. Now we have to make it to the you have to assign a electric perfect boundary, perfect electrical conductor, perfect electric. Similarly to ground also we have to define. Okay, now we have to give a port for that. For the port, first of all you have to change the grid plane, because it has to be made in the YZ plane. Okay, vertically like this. Go to the modeler, grid plane, YZ. Use the sheet option in order to create the wave port. Okay, like that we should do. Zoom it. Okay, now give the dimension as ls by 2 comma minus 6 times of wf by 2 6 times wf, and z size will be 5 times of ts. The thing is, generally we are testing in the real scenario, we are testing with the connector, SMA connector or any other SMP connector. So in that time what we are saying that generally this feed has to be connector has will be edged with the ground plane as well as the 5 times effect will be there from that energy. So that's why we are giving this kind of a port. Okay, as you can see it is a little bit outside only, it is going to outside only. No, it not an issue. Okay, now what we will do, we will create one thick backing. I'll change the selection mode to faces. I'll select the face, edit, surface, create object from the surface. Okay, now what I'll do, edit, surface, thicken sheet. I'm giving a 0.5 only, just in previous case as well. Anyway, we can give it 0.1 also, but since I'm using it for some different dimension also, that's why I'm using this. Now this. We'll assign the material as PEC. Okay, to this rectangle we will assign our boundary here, which is assigned excitation, which is port. Wave port will create. So this is our midpoint. So I'll select the I have to select the lower midpoint. Next, renormalize all mode, finish. Okay, now our port has been completed. Now we have to analyze it. Not analyze it, sorry. Analysis setup has to be made. So go to the project manager, add solution setup, then advanced option you choose. Our area of interest will be 28 gigahertz. Okay, so 28 gigahertz we'll select. Okay, we'll click on OK. We'll select the range as 24 to 40. Anyway, so much of higher value we do not need. We'll also create the open region at 28 gigahertz. Okay, this we will hide. Okay, anyway, it will not affect any simulation only. Okay, I will save it again, and we'll see whether it is validation check is correct or not. Yes, it is correct only. Now we will analyze it. We'll click on HFSS. We'll go for analyze all. So once I'll show the progress event. So once this progress will be completed, we will move to the S11 result for our antenna. Once if you are understanding the steps, how to use the tools and all, and coordinate, how to fix the coordinate, then it will be easier for you, especially in case I'm talking about antenna. Okay, any other tool also you have to understand the parts of it which are available, tools, and some key shortcuts you should know regarding that tools. Okay, so it is completing actually. I will clear the ground only. Since it is having a very long range of frequencies from 24 to 40, around 16 gigahertz, so definitely it will take some time from 5 to 10 minutes. But while plotting the results, it is not at all take time. Okay, in case of CST, whoever attended my previous course, which was based on CST antenna, CST tool, that time also you might have known that it will be taking time, but S11 all other parameter will by default it will evaluate. Okay,